What does the word heterogeneous mean? What's the prefix hetero mean? Different, right? A heterogeneous equilibrium. This is involving reactants and products that are in different states. So in this example, here we have a solid and a gas. The previous examples, everything was a gas, which was nice because gases are once we learn how to think about them, they're easier to deal with. The concentrations of pure solids and pure liquids are excluded from the equilibrium expressions because they're essentially constant. If you have calcium carbonate, which is a solid at room temperature, as long as you have some, the concentration of it is the same. Concentration is the amount of, one way to define it is the number of moles per liter, right? Moles per liter. Number of particles in a given volume. Well, the concentration it's a little bit like density then. The concentration of this is not going to change. Changing concentrations of reactants affected the rate of equilibrium, right? But if the concentration isn't changing, it's not going to affect the equilibrium. So anything that's a pure solid, like these two guys, or a pure liquid, because liquids, like solids, their volumes don't change. If you've got the pure liquid, its concentration doesn't change. We leave those out of the equilibrium expression. So for this reaction, the equilibrium expression is just the concentration of CO2. This is a solid, that's a solid, and so we leave those out because their concentrations can't change. So let's do this one. Write an equilibrium expression for this chemical reaction. KEQ equals. So water. This has the physical state here, liquid. Does the concentration of water change? No, it's always the same. So we're going to leave that out of the expression. So we don't have to put that one in. This is a gas. Think about a gas. When you take a gas and you compress it so that it's higher pressure, that changes essentially the concentration of the gas, right? Because now you have more particles in a smaller area or volume. And so you're going to have more collisions, and that's going to affect the rate of a reaction. So we will include gases. So we're going to put that in as Cl2 raised to what power? The second power, because it's 2 Cl2. And then what goes on the bottom? HCl to the fourth power and O2 to the first power. These are both gases. Gases are compressible. Their concentrations can change, and so we have to include them. But liquids and solids get left out.